All right, welcome to the last part, the last video for our multivariate data summary. And it is, of course, the conclusion, right? So we have the slideshow open that has been uploaded week 1, term 4. So that's the latest one. And if we were to write our report, of course, our next part would be conclusion. And this is where we try to answer the question, the problem we talked about in the first part. So everything in the middle, the plan, the data, and the analysis, they are there to just guide our way and to make sure we are reading off of the right data. And of course, if the conclusion comes out odd or strange, we can go back and look at those other steps to see what could be improved. So let's head on to the conclusion. The conclusion is, or the problem is, let's head back up to the problem. Of course, our example question here is, of course, the kiwi bird weight, right? So if you're watching part 3, I think this is weight. This is part 3, part 4. Part 4, then we already know what the topic is. So let's head back to the problem statement right here. I wonder if the weight in kilograms of female kiwi birds tend to be larger than the weight of male kiwi birds from kiwi birds in New Zealand. Cool, that was the problem. Having said that, now we are trying to say, okay, it does tend to be the case, or we say it doesn't tend to be the case, or we say we don't know from this inquiry or from this statistical investigation, we just don't know. We cannot make the call, which is why we either say we can make the call, we can conclude, and then we carry on that sentence, or we say we cannot conclude, we cannot make the call, and we will follow up with our reasons. And I'll tell you, we'll talk about how this happens. All we're looking at on our, this is frozen for a bit. There it is, it's back. All we're looking at right here is this part. Now this is our big essential part. The median, that line is where the median is, isn't it? We can find out where exactly it falls on that graph in terms of the number by looking over here. That's the median. And of course we can do the same for this one. So that's the median and that's the median. Right? The two different medians for the two different samples, the two different groups. Let's just, yep. So the question is, does the median for one of the group fall within the box of the other group or outside the box of the other group? Now in this case, we can clearly see that it falls outside of the box, right? So the median for the first group, which is the female kiwi bird group, the median for the female kiwi sample falls outside of the box of the male kiwi bird sample. Likewise, we can talk about the other one as well. The median for the male kiwi bird sample falls outside of the box of the female kiwi bird sample. So that's the only part we're looking at. I know it crosses the line, the whisker, you may call it. I know it crosses that, but we're only concerned about this box there. Does it cross it? Does it not cross it? And that's what's important to us. Okay. Now, having looked at that, we go to our slideshow on Google Classroom, and we look at these little bits here. We have case 1, we have case 2, and case 3. These are our keys pretty much. This is it. This is the one that we need. Out of the 3, we look for the one that concerns us, the one that matches our graph. So case 1, it's when both of the medians lie within the box for each other. So both of the medians lie in the box of the other sample. In this situation, this is what we write. We cannot conclude, right? Now, we don't say individuals in population B. We say we cannot conclude that female kiwi birds tend to be heavier than male kiwi birds. So instead of population B and A, we write things like that, right? We will put in the words regarding our investigation, our data, right? And we say because both of the medians lie within the middle 50% of the other sample, right? And the boxes overlap as well. That's a side thing, but we're not too concerned about that right now. This one is when one of the median falls outside of the box, but the other median falls inside. So this is where we say we can conclude. So this is statistically different enough that the sample median and the sample data seems to be different enough that we can say, oh yeah, male kiwi birds and female kiwi birds, there's a difference there. So this is where we say we can conclude that the kiwi birds in the female population are likely on average to be heavier than those in, and instead of population A, we say the male kiwi bird population. Because although the middle 50% of each group sample overlap, one median lies outside of the box of the other group. All right, cool. Right. Now this is where both of the medians lie outside of the box. Right. Now I know this table is talking about box overlap as well. We won't be too bothered about it right now. So don't worry too much about it. But this is the case for us. Case number 3. This is the one for us. For this kiwi bird sample that we're talking about here, this is the case that matches our data. So let's have a look at it. What do they write? We can conclude. So let's write that in. And let's see what that looks like. So we say, we can conclude. And just look at the words that I changed. It'll be very similar, but look at the words that I changed. We can conclude that female kiwi birds, right? Now, we don't say sample anymore. We're trying to make a guess about the entire female kiwi bird population, not just the 700 that we've measured. So we're trying to make a conclusion about the entire population, right? From looking at a small sample. So we can conclude that female kiwi birds will tend to be, this is important, heavier, right? Instead of longer on the slide, I'm gonna write heavier because that we were measuring weight, on average, then those, instead of saying those in population A, we say then male kiwi birds. Because, and then I said, let's forget about the boxes or not overlapping and overlapping. Let's leave that. I'm going to skip to because both, medians lie outside the other box. Right? So I am almost taking this exact sentence. I am taking out the box part. But I am, and I am changing the words like individuals in population B to whatever suits my data. Right? So the words that I've changed, here they are. And you'll change the same words, right? You change words like this one. Will tend to be, instead of longer, I said heavier. Right? And then instead of individuals in population A, I wrote male kiwi birds. But otherwise, the sentence is the same. Remember, don't forget this word, by the way. This is a very important word, tend. But anyway, those are the important bits. That's what needs to happen. And if I was making the conclusion that this summarizes it, right? And if I were to write anything more, I can write a few things. I can talk more about this conclusion and why this makes sense. So we are just repeating what I've said before and just what the learning is. And we still want to write that all in. So we say we We can conclude this because the difference between the two samples is large enough that we can, oops, that's spelled wrong, confidently assume that the difference exists in the population as well. Remember the difference between sample and population. Sample is the one that we've picked out so that we can make this graph and things like that. The population means all, even the ones that we did not check, even the ones we don't have in our data. So if I said the height of every student in New Zealand, right? There's no way I'm measuring every single student in New Zealand. I might be working and making graphs out of a sample, maybe a sample of 120 or 200 students, and get their height and work out averages and stuff like that. But we are trying to conclude for the whole group of people, which is what we're calling the population. So even though we have a sample of kiwi birds, we're saying the difference in the sample is enough that we can conclude some assumptions about the population. Right? The population being all kiwi birds, all male and female kiwi birds. Right? Now this last part I'm gonna leave out as optional for you, but the thing we could do is, are there any ways that we can make this work? All the work that we've done, starting from the problem all the way down, our plan. Would there be any other way that we could improve our conclusions, improve our accuracy from the plan onwards? Could we change some of the data? Could we change the way that we've gathered the data? Could we change or any of the processes that we've done so far? Even if you can't change it, if you know that, okay, some of these things might have caused it to be less accurate, or some of these data points, the way that it was gathered, might have caused some problems and made it harder for us to make this conclusion, or maybe it alters the outcome a little bit, alters the accuracy. Yeah, mention those things. But otherwise, that's the last thing we talk about. And we are now done. So this is how we would end this assessment with our conclusion. We can conclude this because, and we explain our conclusion. We say the two sample is the difference is significant enough that we can say that the population difference is definitely there. Or if we can't conclude, if they're too close, if the medians fall within each other's box, then we say we can't conclude. And in this part, in this paragraph here, we would say something like, we can't conclude because we can't conclude which one's higher or lower, because if it's that close, we're not sure that it's just sample variability. We don't know if it's something that is just random chance when we were picking out these samples, whichever random kiwi birds that we've happened to find and measure, maybe it was just chance that has dictated that females seem to be slightly higher than males. If it's too close, we say we can't make the call that it's true for the population, and that's what we would write in this section here. Otherwise, that's it. And this concludes our multivariate assessment. All right, all the best, everybody.